So today we are learning about matrices. And what is a matrix? A matrix is just when you have numbers that are arranged in rows and columns. Numbers, or any kind of data really, arranged in rows and columns. And actually the first thing we have to talk about is what's the difference between a row and a column? A row is going to be horizontal, where a column is going to be up and down. So when we name a matrix, we name it row by column. So row by column. So if we look at this first matrix and I count the number of rows, there are 1, 2, 3 rows. So it's got 3 rows. By the number of columns here is only 1. So this is a 3 by 1 matrix. The next matrix here is got 2 rows, 1, 2, by, I think you'll agree, 1, 2, 3 columns. So it's a 2 by 3 matrix. What do you think the row and columns are for number 3? You are right. It is a 2 by 2 matrix. How about the row and column for number 4? You are right. 1 row and 3 columns. So a 1 by 3 matrix. That is how we name our matrices. Then if we're going to add matrices, this is going to be pretty intuitive, right? So if I want to add matrix R plus matrix S, I'm just going to look at the corresponding numbers. And by the way, I can only add matrices if they're the same dimensions. So a 2 by 2 matrix can be added to another 2 by 2 matrix. And my answer will be a 2 by 2 matrix. -4 plus -2 is -6. +2 plus +2 is +4. -3 plus -6 is -9. And then 5 and 0, of course, would just be 5. You don't have to show any work, right? You can pretty much do that all in your head, adding 2 matrices. This is a little trickier. I'm going to multiply a matrix by a number, and then multiply this matrix, and then subtract them. So if I do 2 times matrix R, 2 times matrix R, I'm just going to take that 2 and distribute it. So I would get -8, 4, -6, and 10. And then I'm going to subtract 3s. So I'm going to take the number 3 then and distribute that just in my head throughout matrix S. And of course 3 times 3 is 0. And then I'm going to subtract them, right? So if I subtract them, 8 minus -6, 8 minus -6, I'm going to write my answer up here. 8 minus -6, wouldn't that just be -2? 4 minus 6, also -2. -6 would turn into plus 18, which is 12, and 10 minus 0, of course, is 10. And you might decide that you can even do more work in your head and not have to solve them. Same thing here. Now we switch our matrices here. So now we've got a 2 row by a 3 column matrix. So if I'm going to do matrix 2T, so then I'm going to take everything in matrix T and double it. So that's going to be what? 10, 0, -2. You could probably even do this in your head. I'm thinking 2T plus 2U. So 10 plus 6 is 16. And then 2 times 0 is 0, of course, plus 2 times 2 is 4, so just 4. 2 times -1 is -2, plus 2 times 0 there is -2, and so on, right? So if we keep going, I believe we're going to get -12 here, and then 8, and then 20. So you are welcome to do that in your head. Similarly with T minus U, we're just going to subtract each spot. So 5 minus 3 is 2, then -2, then -1, then -2, -3 minus 7, -10, and of course 5 minus 5 is 0. Adding and subtracting matrices. Multiplying matrices is a little bit more difficult, but it's not bad. So when you multiply matrices, we do this column times row, column times row. So if I'm going to multiply matrix A, I'm going to rewrite it here. So matrix A is my 1, 2, 3, 4. 1, doesn't want to write here for me. 2, 3, 4. Let's try that. It's too close to the edge. Try it here. 1, 2, 3, 4. Anyway, and oh, there we go. Yikes. And then 1, 2, 3, 4. I'm going to multiply that by matrix B. Multiply that by matrix B, which is -3, 5, 2, -1. Okay, fine. So now what I'm going to do, after I can write this down, which it doesn't want to do. Let's see if I do it with my finger. So -3, 5, 2, -1. Okay, so we're going to take every column and multiply it by the row. So we're going to take this column here, this first column, with the 3 and the 2. Come on. There we go. And we're going to multiply that by the row. So what we're going to do is we're going to take the 3 times the 1, which is 3, and then we're going to add that to 2 times 2. 3 times 1 is 3, plus 2 times 2 is 4, and 3 plus 4 is 7. If I switch colors here, then I'm going to do just scooch over and do these two, okay? So if I multiply 5 times 1 is 5, plus -1 times 2 is -2, and 5 minus 2 is 3. It is a little tricky, but you'll get the hang of it. Then if I scooch over, really, again, so I'm going to take now this row, the 3 and the 2, and multiply that by the 3 and the 4. So 3 times 3 is 9, 4 times 2 is 8, 9 plus 8 is, right, 9 plus 8 is 17. Although I'm feeling like I messed up, because wasn't that a -3? It was, my circle messed it up. So it should have been -3 times 3 is -9 plus 8. And -9 plus 8 is -1. So now I want to go back to that first one. Okay, I just kind of went and redid this problem here because -3 had gotten a little bit messed up. So again, I'm going to multiply the row by the column. So -3 times 1 is -3 plus 4. My first answer should have been 1. -3 plus 4. Then if I scooch it over, now I take this column times this row. 5 times 1 is 5. 2 minus 1 is -2. So 5 minus 2 there is 3. Then I'm going to go back to this column and this row, giving me -9 plus 8 is -1. And then finishing it up here, oops, change colors again. So here would be 5 and 1. So it'd be 15 minus 4, which is 11. And that's the answer. And I know that that's tricky. So let's try it again. We're going to try it now with B times A. You might say, didn't we just do that? Well, we actually did A times B, which is slightly different than B times A. Actually, not slightly different, really totally different. So 1, 2, 3, 4. So now when I write it this way, which is B times A, I'm going to get completely different numbers when I'm multiplying the column times the row. So 1 times -3 is -3 plus 15. -3 plus 15 is 12. Then if I scooch over to this one, 2 and 4 times -3 and 5, this is going to be -6 plus 20. -6 plus 20 is 14. If I come down here now, 1, 3, and -2, 1, so it's going to be 2 minus 3, which is -1. And then if I finish it out here with the 2, 4, and the 2, -1, so I get 4 minus 4 is 0. So you could see it was a totally different problem when we switched the order. Next one here is CD. So we're going to move on to a little bit of a different shaped matrix. And again, notice I'm keeping the numbers really easy. 1, 2, 3, 4, 5, 6, as easy as we can. 5, 6. And we're going to multiply that by D, which is 1, 2, 3, 4, 5, 6. 4, 5, 6. So this matrix here, you wouldn't think you could multiply them together, but you actually can. What was that? So undo. So you wouldn't think you could multiply these together, but you actually can because they match up. So if I say this column times this row, there's a numbers partners for everybody. 1 times 1, 4 times 2. So 1 plus 8 is going to be 9. So we'll write that here, 9. Then if I scooch over here, let's say, so this is what, 2 and 5 times 1 and 2. So 2 times 1 is 2 plus 10 is 12. Similarly, if I scooch over again to this 3 and 6 and the 1 and 2, I get 3 plus 12, which is 15. So you're seeing the answer matrix grow here, right? And if I keep going, I'm going to fill in with these numbers. 19. How am I getting 19? Well, it's back to the 1, 4 now times the 3, 4. So 3 plus 16. Then I scooch over again, 2, 5 times 3, 4. That's going to work out to be 26, 33, 29, 40, and then 51. And I'm just marching along that same order. Now, I might notice that originally I had a 3 by 2 matrix, and I multiplied that by a 2 by 3 matrix. And I was allowed to multiply them because the number of rows and the number of columns matched up. In other words, these inside two numbers were alike. And then my answer matrix is going to equal the outside two numbers. So you can see that the answer matrix is a 3 by 3. And I know that that one's tricky. Next one will be less tricky because we are going to introduce what we call the identity matrix. The identity matrix has zeros everywhere and then ones kind of on the diagonal. And what's beautiful about the identity matrix, well, you'll see. So if I have my matrix C, 1, 2, 3, 4, 5, 6, and I'm going to multiply that by the identity matrix. Doesn't seem like you can multiply them, but you actually can. This was a 3 by 2 matrix and a 2 by 2 matrix. The inside numbers match up, so the outside numbers are going to be, my answer matrix is going to be 3 by 2. But that will become really clear here in a second anyway, here, because if I'm going to multiply 1 times 1 plus 2 times 0, isn't that just 1? Yes. 0, 1 times 1, 2. Isn't that just 2? Yes. Switching colors, right? 1, 0, 3, 4. 1 times 3, 4 times 0. Isn't that just 3? Yes. 3 times 0, 4 times 1. 4. Are you seeing the pattern? How are we going to finish it out? 1 times 0 and 5 times 6 is 5. And then 0 times 1 and 5 times 6 is 6. So what happened is when you multiplied the matrix times the identity matrix, you got itself, right? It was itself. And that's true of all identity matrix multiplication, whether you're multiplying by the right or the left. Okay, let's see, where are we at? So what do we have to do? Oh, determinant. So this is just a formula, AD minus BC. This is going to make more sense as time goes on. AD minus BC. AD minus BC. Where A and D are the numbers on the first diagonal, B and C are the numbers on the second diagonal. So here, if I multiply 1 times 3, I get 3. And then I'm going to subtract, 3, writing it with my finger. And then I'm going to subtract 4 times 2, which is 8. So 3 minus 8 is negative 5. For right now, that doesn't make sense to us why we need to know that, but it will make sense, right, tomorrow. So here, if I multiply negative 5 on the diagonal minus, it's always subtracted, 10 times negative 2 is negative 20. And so if I add those up, I'm going to get 15. Right, I'm using my finger here. Negative 14 minus negative 32. So negative 14 minus negative 32, 18. Here, 1 minus 1, 0. So a determinant can be 0. And again, that's just a rule. And the last rule that we're going to learn for today is the inverse of a matrix. And the inverse of a matrix is 1 over determinant, that AD minus AC. And then I say switch spots, switch signs. Switch spots, switch signs. I'm trying to write it, it's not going to let me. Switch spots, switch signs. So which spots do you switch? Which signs do you switch? We're going to switch the spots of the A and D, right? The A and D is going to become D and A, and then B and C here become negative B and negative C. So first thing you do is the determinant, which I can just kind of do that in my head, right? 3 minus 8, or it's the same one we did there, negative 5. So it's 1 over negative 5, and then we're going to switch spots, switch signs. So 3, 1 is going to become here, and then negative 2, negative 4. We don't distribute the fraction through. That just is our answer, right? That just is our answer. So here we have 32. If I multiply on the diagonal, 32 minus 6 is 26. So 1 over 26. Switch spots, switch signs. Negative 8, negative 4, negative 3, negative 2. Switch spots, switch signs. This one's going to be kind of lucky here, because when I do my determinant, do you agree I get 25 minus 25, right? 25 minus 25, which is 0. What's 1 over 0? Can't do it. Empty set, doesn't even really matter if I switch spots, switch signs. There is no inverse. You might recognize this as the identity matrix, so 1 minus 0 is just 1. And then when I switch spots, I still have 1 and 1, and when I switch signs, I still have 0 and 0. So the inverse of the identity matrix is equal to the identity matrix. Those things at the bottom will be more clear to us tomorrow, but this is it, matrices number 1.